Hi John, this is Ross. Hope I can help with this problem. I think the last video wouldn't upload, so hopefully this one will work. You have some information about some trees you're trying to plant and you want to deal with an inequality. You have $720 to spend on the project. You don't want to spend any more than that, but you're willing to spend up to $720. You're going to spend $120 each on these larger trees and $80 each on the smaller trees. So for part A, we need to start by just defining our variables, which are up here. I've done that already. So we have X being our larger number of larger trees and Y being the number of smaller trees. And that means that for when we buy larger trees, we're going to spend $120 on each of those larger trees. So that'd be 120 times however many there are. So that would be X. And when we buy the smaller trees, not the 720, the 80, right? That would be $80 times Y. So 80Y would be the cost of all of your smaller trees. And the total cost of our project would be the sum of those. So we just add them up. So to get our inequality, we need to know what symbol to use. So with inequalities, we can use a less than, a greater than, less than or equal to, greater than or equal to. In this case, it says we want to spend no more than 720. So I'm going to put a 720 at the end. And no more than means we can spend everything less than 720 and we can spend 720. Because no more than means we don't want to go over it, but we can spend 720. So this is a case where we'll use less than or equal to. So that's going to be your inequality for part A. 120x plus 80y should be less than or equal to 720. Graphing inequalities can be pretty tricky. There's a few different ways to do it. The easiest way in this case is going to be to find your x and y intercepts. Remember that an x-intercept is the point where a line crosses the x-axis, and this will make a line since it's a linear inequality, 1x, 1y. And a y-intercept is where the line crosses the y-axis. That gives us some really important information with just those 2 points, because for an x-intercept, no matter what the x value is, the y value has to be 0. Because we're on the x-axis, we're not going up or down at all. And it's just the opposite for a y-intercept. The x value is 0, no matter what the y value is. Because we're on the y-axis, we're not going left and right. We can use just the 0 for each of those then to find these 2 points. And we do that by plugging into this inequality. So for example, with let's do the y-intercept first. I'm going to plug this x for 0. I'm going to plug that into x in our inequality. So I'd have 120 times 0, which is just going to be 0, cancel out, plus 80y, because in this case, I don't know what the y value is. That's what I'm trying to find. And then that should be less than or equal to 720. Well, with this 120 times 0 gone, all that's left to do then is to divide by 80 on both sides. And that'll leave us with y is less than, oh, excuse me, this should be equal to. Y is equal to 9. That's my mistake. In this case, we're actually going to ignore the inequality for a second, because when we're finding, so that's going to be equal to also, when we're finding the intercepts, we're trying to find just that 1 point. So that's where we want the equation to equal something, not where it needs to be less than or equal to. So when we're dealing with these intercepts, you don't need the inequality. So y is going to equal to 9, and that means that the y value here will be 9. And then we're going to do the exact same thing for the x-intercept, except now we're going to plug 0 in for y. So I'm going to have 120x. X is back to a variable because I don't know what that is right here. And then I'm going to plug in the 0 for y, so plus 80 times 0. So now that's going to go away. And then still, oop, I did it again. Since we're dealing with an intercept, we just want that to be equal to 720. So that's just 120x equals, drawing weird equal signs, 120x equals 720. And then divide by 120 on both sides, and you'll find that your x-intercept is going to be at x equals 6. So we found those 2 points, because to draw a line, all you need is 2 points. So I'm going to go ahead and try to do that here, if it doesn't give me too much trouble. Kind of close. So there's our line that would go through those 2 points, or somewhere close to it. You might remember when we deal with inequalities, sometimes you draw a dotted line, In this case, we're not going to do that. We're going to keep it solid because of this equal to bar. Anytime you have less than or equal to or greater than or equal to, that line should be solid because points on that line can be solutions to the inequality. We also, because this is an inequality, need to do some shading. You may remember that we need to shade either above the line or below it. And since this is a less than sign, we're going to shade below the line. So I'm going to go ahead and do that as much as I can. So we're going to shade in here, below the line here. Everywhere below that line gets shaded in because all of those are solutions. So that's part B. Now, before we go into part C, I want to point out something about what we just did with the shading. If you think about what that means, all we're doing when we shade those in is we're saying any point that we choose in the shaded area, so any of these points that I'm drawing, any of those points can be solutions. If you take those coordinates and plug them in up here into your x and y, you'll end up with a number that's less than or equal to 720. But some of those points don't actually make sense in terms of this problem. So for example, this first one I drew over here, that might be, let's say, -2, 4. If you plug those in, you're gonna get a number that's less than 720, which is great because our budget should be lower than that or equal to. But -2, 4 doesn't make any sense really if you think about this problem. Can you think about why? -2, what is our x value? Our x value is a number of larger trees. There's no way to have -2 larger trees. So having a negative number in this problem is nonsense. For the inequality, it technically works, but if you think about what the problem's asking, we need to ignore any negative numbers. So what I'm actually going to do is I'm going to go back and erase this shaded part because that has negative x values. And I'm going to erase this bottom shaded part because that has negative y values. So any of those points, even though they technically fit the inequality, they're technically solutions, they just don't make any sense for our particular problem. So with that, part C, back to that, says what is the greatest number of small trees? Well, smaller trees are our y variable, so we need to look at what's left and figure out the very biggest our y can be. So what's the highest we can go on this graph? Well, the line technically goes up and up and up and up forever, but we would have to stop at that y-intercept because any further and we get back into those negatives that I just talked about. So at that point, the y value is 9. You could buy 9 smaller trees and spend exactly 720 as long as you don't buy any bigger trees. So that's the answer to part C. And then part D is just kind of adjusting a bunch of this. So if you decided to spend 40 bucks on a rose bush, that means instead of 720, we would put 680 here. We can just take the 40 out of the 720, and then everything we spend on the trees would have to be less than or equal to 680. And then you could go about finding your intercepts the same way. I believe the y would end up being 8.5 this time, and the x ends up being about 5.7. So that would also adjust some of your other answers because you obviously can't buy half of a tree or 0.7 of a tree. So in part C, for example, if your intercept is 8.5, then the most small trees you could buy would be 8 because you got to round down. So that's all those different pieces. Inequalities, can be tricky. They've got the actual inequality, the algebra, the graphical piece, interpreting with the word problem. But I hope that helps you to tie all of it together and understand this type of problem a little better.